So, this is what you use when your equation is in vertex form. So vertex form is y equals ax minus h squared plus k. So if you have this form here, you are going to use the square root property.
That's rambunctious.
So to do this, the first step is to get whatever is squared by itself. So whatever is squared needs to be by itself. It needs to be isolated. It will be an x squared term if there is no middle term, that no bx term.
Wait, no, what?
Mike, please go back to your seat.
Alright, I'll be good.
Mike. So if there is no bx term, then you can also use that. That's like standard form, right? If there's no bx term, that's what I'm referring to there. Then you're going to use the square root property by taking the square root of each of the equations. Okay, guys. On your calculator, you guys all have like an x squared button, right?
Yeah, sure.
If you hit second and then that button, for most of you, do you guys see that this comes up? That's the square root symbol. That's where you'll find it.
I got answer 2.
That's fine. That's
See, I was.
yours. You see it already. Yours should just be there. Yours should just be on it. Yeah. Those of you that have Casios, it's just like a button already on there. Anyways, so we need to think about this. This is where a lot of you guys are going to go wrong. When you take the square root of 16, you get what?
4.
That's because 4 times 4 is... 16. What else is 16, though? What other numbers can you multiply together to get positive 16? No, same number times the same number.
8 and 2. Nothing.
Same number times the same number.
There's one other thing.
4.4.
No.
2 positives make a positive and 2.
Negative.
Oh my
Negative 4,
god.
negative
That was a trick question.
Which really means that if you take the square root of 16, you can have 4 or negative 4. You have 2 answers. And let's think about why that is. This is where you guys are really going to get lost. So you're going to lose one of your answers along the way. When I typically have a vertex, how many times does it cross the x-axis?
2.
Twice. So we need to be getting 2 answers because we are solving the equation in vertex form. So essentially what we are doing today is we are saying, when does our parabola cross the x-axis? Well, we know that y is 0 when we are crossing the x-axis, right? We know that parabolas typically, not always, but typically cross the x-axis twice. We do have cases when it's not. So typically it is 2 times. But sometimes we will have a vertex sitting on there, so it would be 1 time if the vertex is on the x-axis. And sometimes it is no times if it is never going to hit it, and that we know is
Imaginary.
Yep, no real solution, no real roots or imaginary. So we do have other times, but most of the time, this is what we have. Right here. Do you guys see that?
Yeah.
You scribbled all over.
So, it is important that when you guys take the square root of both sides, you get 2 answers. Okay, that's going to be where you forget things. So then you're going to write both simplified answers as part of your solution. Again, the word both is in here. Okay, so let's go through this. Go ahead and flip to the next page so we can go through examples. I'm pretty sure there's no word problems today, unless I'm wrong. Yes, so we'll just go through as many as we can get to. All right. So let's go through this. So before, can you stop talking? Stop. Hey, Mike, stop. So before, to find our roots, our zeros, our x-intercepts, to solve it, we just looked at a graph and we kind of said between these values. But when you use algebra, you can get like a decimal answer. All right? You can actually get an exact answer, but we're not going to talk about that. You'll get to that in Algebra 2. So we'll be using our calculators to get a decimal answer. So just think about this. Before we even solve this, if we were to graph this, what would my vertex be? We would have a vertex at -7, -4. And we would use our pattern. And our pattern for this one is being multiplied by 1. So we go out 1, up 1, out 2, up 4. And you'll notice that we do get exact answers here, right? It looks like we should get an answer at -5 and -9, right? When x is -5 and x is -9. So let's see how this works algebraically. You okay?
Yeah. No.
Do you need to go?
I need a drink.
Go ahead, go. So, to solve this, the first step is to get whatever is squared by itself. So do you guys see that that is being squared? So what do we need to move? What is not letting it be by itself?
-4.
So we're going to add 4 to both sides. Now that that is by itself, we can use the square root. Because to undo something that is squared, we take the... So that goes away there. So if you take the square root of 4, your calculator is just going to tell you it is 2. We know 2 times 2 is 4. But what's another thing that is 4? So really, we get a positive and a -2. So we actually have 2 equations here, which makes sense because we know from graphing this that we should be crossing the x-axis twice, which means we should have 2 solutions, so 2 things to solve. So once you get here, you should realize 2 times 2 is 4, and -2 and -2 is 4. This is different for you guys, because you're so used to when you solve, it's just one thing, right? So you guys got to get used to whenever I take the square root of both sides, I get 2 answers, okay? That's going to be the hard thing for you guys. So this does separate. We get a positive 2 equals x plus 7, and a -2 equals x plus 7. So this will show you that it will allow us to get 2 answers. And we already know that it should be -5 and -9. So if I subtract 7 on both sides, I get x is -5. And if I subtract 7 on both sides, I get x equals -9. Is that where our graph crossed?
Yeah.
It is. So this is how you solve it algebraically. So you can write it up this way, There's 3 ways I'll let you guys write it up. Or you can write it up as a set of numbers. I honestly do not care which one you do it as. All 3 of those are appropriate ways of writing it up. And I like to show you those just in case the EOC gives you different ways of doing it. So you guys are aware of what those all mean. So that's the first one there. Now this one has a vertex at what? Where's our vertex?
5.
And that doesn't really fit on our graph well, does it? So in these situations, it's kind of hard to graph that. So is it good to know algebra to be able to figure it out? So we said the first step is to isolate what is being squared. So do you see that I didn't put that 3 inside of my circle? Or my square, I should say, or rectangle? Do you see how -3 is outside of my rectangle? That's because the only thing that's being squared is this x minus 5. So we need to isolate this piece here, or get it by itself. So Connor, what would be the first thing you would do to isolate it?
Subtract the 12.
You need to move the 12 first. So we subtract 12 and we get -3 equals x minus 5 to the second power. Is that isolated yet? No, there's still a -3 out front. So what is my next step, Josh, if there's a -3 out front? Negative 3 is touching the parenthesis, which means multiplication. What is the inverse of multiplication? Division. So we are going to divide. So I get 4 equals x minus 5 squared. Am I now isolated? Is there anything outside of my box?
No.
No. So we are good to go. So I am going to take the square root of both sides. This is where we have to be careful. We already know that the square root of 4 is 2, right? Because 2 times 2 is 4. But what else is 4? So this is actually plus or minus 2. So this actually gives us two equations. And we can look at this. I'll show you guys with the graph and show you guys how to check everything. What's wrong?
Well, I wasn't here for the first problem, but why would...
Because 2 times 2 is 4 and negative 2 times negative 2 is 4. And if you look at this first problem, you can see that it is crossing twice. So we need to somehow be able to make 2 different equations to solve so we can get 2 different answers. Because what we are trying to find is where is my graph crossing the x-axis because y is 0. Do you see how y has been replaced with 0? That means we haven't moved up or down. So that's why we split it into 2 different equations. So I get 2 equals x minus 5 and negative 2 equals x minus 5. And then I solve them. So I get x equals 7 and x equals 3. And I said you could write this up in so many different ways. I don't really care which way you do it. I'm going to do these 2 ways this time. Those both work. So let's think about this. Do these solutions make sense? If my vertex is at 512, which is kind of up here, right? Does it make sense? Will this cross the x-axis? Is it negative? Yeah, so this is going to open down, right? So it will cross it. So typically if we go out 1, it's down 1. But in this case, we have to multiply by negative 3. So we should be trying to get to 3 and 7. We're saying that this parabola should look something like this, right? Do you guys see I'm just plotting my solutions with my vertex? You missed the first example. You're going to have to catch on here a little bit here, Riley. So you'll notice I plotted 7 and 3, which we got as our solutions, and the vertex. So we're saying it should look something like this. So let's just check. If I go out 1, I go down 3, which would put me over here. I just didn't put it at the right spot because of the graph I'm dealing with. So this is about right here, right? And then if I go out 2, I typically go 4, right? What's 4 times negative 3? So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do I hit that? If I go out 2 and I go down, I go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yeah.
So do you see how these two things are the same? Before, you had to solve by graphing it and just look at it and say, well, I can tell it's crossing at these 2 points. But when it was not an exact answer, you had to say between the 2 points, right? But with algebra, we can get an exact answer. So these ones are going to be exact regardless. So we're going to talk about sometimes that we get these decimal answers. So go ahead and, you don't have to flip yet. So we're going to look at the next examples now and see where we're at. So you'll notice in this case here, we have x squared here. Do you guys see how we have no bx term, no middle term?
Yeah.
That's why this one is still in vertex form. Now, what is the vertex here? 0, negative 8, right? There's nothing between. So 0, negative 8 is down here. In my pattern, my a value is, what's my a value?
9.
Oh, I just wrote that wrong. My a value is what?
1.
1. So we'll go out 1, up 1, out 2, up 4, out 3, up 9, right? And you'll notice, are we crossing at an exact point here?
Oh. Nice.
So these were the situations. I did something wrong again.
We're on the wrong graph.
I'm just so proud of you that that's what you always end up doing. So do you guys realize that when we graphed this one before, we had to say between negative 2 and negative 3 and negative 2 and between 2 and 3. Now we will be able to figure out what that decimal is that we were trying to find because we know algebra. So the first step is to isolate the squared term. So we're isolating the squared term. So Brian, how would I isolate that squared term? What would I do first?
We're still on
Number 3, yep. It takes a long time.
isolate the first term.
The x squared term. How do I isolate that? The negative 8 is not letting it be by itself, so what do you have to do with it?
You add it.
We add 8 to both sides. So we look at our x squared term. Is there anything in front of it or anything being added or subtracted to it anymore?
Nope.
No, so we are isolated. So this is when we get to take the square root. Is the square root of 8 a perfect square?
No.
No, go ahead and do the square root of 8 in your calculator,
Wait,
David.
yes, it is. No, it's not.
Let's round to 2 decimal places.
2.8.
You hit S to D.
2.8.
So I want fractional answers, or decimal answers, I mean. The second, x squared, and then type the number in.
2.83.
Yes. So it should be 2.83. You're rounding to 2 decimal places. So we have x equals 2.83, and that's rounding, so that's not exact. So we're saying 2.83 times 2.83 is going to get us 8. What else could we multiply to get 8, though? We even can see that on our graph that we need to have 2 solutions somehow, right? So remember, whenever we take the square root of both sides, we have to take the 2 positives and the 2 negatives, because those both make a positive number. Is anybody confused on how people got 2.83? Did anybody not get 2.83? It's okay if you don't know how to do it. You need to ask if you don't know, though. Okay, so yeah, if we split this equation here, whoops, where did I get that from? If you split this equation here, you have 2.83 equals x, and negative 2.83 equals x. Do we have anything to move next to the x? No. So we are done. And you can kind of tell that that would make sense that it would be 2.83 and negative 2.83, right? Where that one's crossing. And again, you can write it up this way as well if you prefer that. That's called set notation, and those are just a set of x values. Or if you really wanted to, you could write them up as ordered pairs, but that's a lot of writing, so I don't know how many of you actually want to do that. I feel like the more writing, the less likely you guys are going to do it. So, all right, so you have to be careful. This is a situation where kids get it wrong almost every single time. Be careful. Yes, technical difficulties. Mike got it.
B.
Be car. Okay, be careful.
Careful.
This. Stop that.
Yeah, stop it.
This x is the only thing being squared. Is this 5 being squared?
No.
No, a lot of kids will think that it's being squared, so they'll just take the square root right away. That does not work. Do you understand me? So you need to make sure you isolate the x squared piece first. So Emma, how would I isolate that x squared piece first? What would I have to do first? Divide by 5. So I get 0 equals x squared.
Wait a minute.
So yeah, this is confusing, right? So if I take the square root of both sides, what's the square root of 0?
0.
0 is neither really positive or negative, right?
Yeah.
Because usually we put a plus or minus here, but that would look kind of funny.
So the vertex is always
0, 0.
This, because this is 0, means that the vertex is on the x-axis. So that's why we only have one solution here. So remember, we have most of our situations are 2, but when the vertex is on. So really, we can't split this one. We just get x equals 0, or you could write it like this, which makes sense. If you're looking at this problem, what would you tell me the vertex is because there's no bx term? 0, 0. And then we would do our pattern from there. So 0, 0. What is our multiplier this time?
5.
Is it positive 5? Yeah. So out 1 times 5 is 5, up 5. And that's all I'm going to be able to fit. Is there really only one intersection on this graph? Yeah, there really is only one intersection on this graph. And it's because that vertex is on there. And yes, Mike, that is stretched. Very true. So, good call.
are these.
I gave him to Connor because I called him something and he got sad. So I wanted to make sure he had some cleanup. Okay, let's look at the next one.
Oh, not the next one.
We have 4 more.
Oh, not the 4 more.
So let's just graph this one real quick. What is my vertex here, Josh? Yep, opposite H, same K. So we do 5, 9. And then we have our pattern. What are we multiplying by this time?
Negative half.
A negative half. So is this one going to open up or down? It will open down. So if I go out 1, it's typically 1, but 1 times negative half means we're actually going down
Half.
half.
Whoa.
Half of 4 is,
2.
so we're going down 2. Half of 9 is, and half of 16 is,
8.
so you'll notice as I'm graphing this, am I crossing at an exact point here?
No.
No, but how many solutions should I have?
2.
I definitely should have 2 because you guys see my graph is crossing twice. Before you would have had to say between 0 and 1 and between 9 and 10, right? But now you are lucky enough to learn the square root property, so you get to do the decimal, Riley. I know that's what you wanted to do. So, yeah, it is more work. You're correct.
Yeah, more likely.
So,
I'm not gonna do anything.
look at this here. That is what needs to be isolated. Do you guys notice that my box is not around the negative 1/2? It is not being squared. The only thing that's being squared is what's in parentheses. What's the first thing, RC, I need to move?
The 9.
So I subtract 9 on both sides.
Why not be doing this?
Because we don't want to be saying between. We want to be able to get exact answers.
No, like the entirety of it. Why are you doing it? Like we aren't gonna use this later in life.
You guys might, but actually people do use quadratics in life.
But I won't.
If we're a math
Not necessarily a math teacher. I'm saying like quadratics are used in different things.
Just use it. Just do it.
Okay, so is that isolated yet?
No.
No, so we have to divide both sides by a negative half. Make sure you put it in as a negative 1/2 in your calculator using the fraction button. And tell me what you guys get.
I got it.
That makes sense. Because
I don't even get to do it.
you can multiply both sides by negative 2, yeah. Does everybody know how to put calculators, fractions in their calculator? Okay. Is it isolated now?
Yeah.
Yeah, so we can take the square root. So when we take the square root of 18, you'll realize that it is not a perfect square. So what do you get out? Round to 2 decimal places.
4.
Try it, Riley. I want to see that you can put it in your calculator. Second, x squared, and then 18. Yep. So we're saying, so that was around to 4.24. So we're saying about 4.24 times 4.24 is 18, as well as, did I write on myself?
I think so.
That's impressive, guys. Is it there still?
No, you're good.
Oh, are you sure?
Yes.
Okay, we're saying positive 4.24 times positive 4.24, or
Negative.
2 negatives can also multiply to get the 18. Thank you guys for actually telling me instead of just leaving it there and like sending Snapchats to all of your friends. No, that doesn't mean you won't do it. I'm glad that that's what you just took from what I just said.
What?
Yeah, let me just post this on Snapchat real quick.
So we have positive 4.24 equals x minus 1, and negative 4.24 equals x minus 5. I think I said x minus 1 the first time.
Yeah, you did.
So this is good that we have 2 different equations because we know it should be crossing at 2 different points here. So if we solve this, we add 5. So do 4.24 plus 5 and you get x equals... It's going to get worse. Just throwing that out there.
Why? Why are we doing this?
What is 4.24 plus 5?
9.24.
And that makes sense, looking at where it's crossing, that it's somewhere between 9 and 10. If I add 5 to negative 4.24, what do I get?
0.76.
So we get 0.76 equals x, which again makes sense because we're somewhere between 0 and 1.
Hold on a minute.
I just put it on the other side, it doesn't matter.
Whatever.
But yes, you could write it that way if you wanted to. Okay. Please stop talking. So we need to isolate this. The negative 2 is not inside of my box. What do I need to do first, Jayla, to get it isolated? So it's being multiplied, so the inverse of multiplication is division. So I have x plus 2 to the second power. Is that now isolated?
Yes.
So now we can use the square root to undo something that's being squared. And what is the square root of 0?
0.
Can 0 be positive or negative?
No.
No, that's weird. So we only have our one equation to solve, which means that what is happening here? Where's our vertex at? Look at that. What is our vertex here? Opposite and then the same, Mike. So negative 2, 0. Because remember, it's x minus h squared, so you have to do the opposite sign. So we do. Our vertex is where at right now?
-2.
Which is on the x-axis, which means we're only going to have one answer. That makes sense that this is only going to have one answer. And our answer, after we solve, is that x equals, which is where we plotted it. Our pattern says we need to multiply by what this time?
-2.
-2. So if we were to graph this,
You go downward.
you are going to go down. So we'll go down 2 and then down 8. So that makes sense. We only have one answer there.
We do.
Okay. Questions so far? We have 2 more.
Yeah, we do.
You skip one?
Did he skip a slide again?
Always skip on.
No. So, the first step here, I just don't know how you're making the connection. They're not even the same problems.
I don't know, but I did the thing I did.
Okay. So, what is the first thing to do to isolate this?
-9.
Is that completely isolated now?
Yeah.
So, go ahead and take the square root of -9 in your calculator.
Alright, you got it.
Everyone do it. Don't say anything.
So,
What?
Domain error.
Excuse me? You weren't supposed to say anything, Blaine.
I think that's the easiest thing ever.
Wait,
Square root is -9.
I did.
What do you
Can't
guys
be
say?
negative.
Hit enter.
3.
See, look, enter.
0.99.
So, some of yours will say domain error, and some of your guys are going to say math error. So, that's because, think about it, you need it to be the same number times the same number to get to the number underneath the square root, which is -9. Will 2 negatives ever get you to a negative?
No.
Will 2 positives ever get you to a negative?
Oh
No.
my God.
This is when we have no real roots, which means that if we go to graph this, if we go to graph this, you can write imaginary.
Can I write a big no across the entire
This is -4, 9. Guys, please stop talking. You guys will notice our graph is at -4, 9, which creates this parabola here. Is that parabola ever crossing the x-axis?
No.
Does it make sense that we have no real roots then?
No. Yes.
Actually, when you guys get to Algebra 2, this is going to be, don't write this down, plus or minus 3i equals x plus 4. And you'll be able to keep solving.
What's I?
Imaginary.
You're joking, right?
I'm not. That's why I tell you guys it's an imaginary solution, because you are going to be able to do that when you get to Algebra 2.
I'm not. Drop out of school this year.
Just say, guys, they're doing that.
No, if you drop out freshman year, always.
Yes. No, I'm not done yet.
No.
All right.
Friends of freshmen.
Last one. Blaine, what's the first step?
Minus, add 4.
Add 4. Be careful, 2/3 is outside of the squaring. So what do you still have to divide by? Make sure you use that fraction button in your calculator. And what do you get? But it's not just, I don't know what I'm doing right now. 6 equals x squared. So now are we isolated?
Yeah.
Yeah, so we can take the square root. What's the square root of 6?
2.45.
It's not just 2.45, it is also.
Negative.
So if we split this, will we have to continue to solve it?
No.
I know, I'm sorry. I'm just going this one fast because
Going too fast.
we've done 8 examples now. So you'll notice that this is 0, -4. And this one will eventually hit the x-axis. I got to think about this 1 second. 4 times 2 is 8 divided by 3 is 2.
Every Friday.
Not Friday and Wednesday.
So you guys will notice a syntax error is different than a math error. Syntax error means you type something in wrong. It's like a user error. You know what I'm saying? Versus like it being a math thing. So you'll notice it is definitely between 2 and 3. Okay.